Hello guys, so today we're solving February March 2023 paper 1-2 chemistry A levels. The first question says 4 equations representing reactions of nitrogen or one of its compounds are given. Which equation represents a disproportionation reaction? So you guys might know that disproportionation reaction is also known as self-reduction, oxidation reaction. So for this, the reaction which oxidizes as well and does reduce as well is known as disproportionation reaction. So let's move to the answers and then I'll explain how it happens. So the answer for this is D. So what happens is that, for example, 2NO2 plus H2O gives nitric acid and HNO2. So what happens is that this O2 has a charge of -2 and the O has a charge of -2 and O2 has a charge of -4, right? This H has a charge of +1, and if we add this, so this becomes -4 plus 1 gives -3. To balance this, the N will be +3. For HNO3, O will give -2 and O3 will give -6. H will give +1. -6 plus 1 is -5, and to balance, N will be +5. For H2O, O is -2 and H will be +2. And 2NO2, O will be -2 and O2 will be -4. And this N will become +4 to balance. Okay, so what happens is that if we look at N, nitrogen, so here it's +4. Okay, here it's +4, but if we move down here, it is oxidizing. It increases by a value of +1 from +4 to +5, so it is oxidizing itself, right? From here to this N, HNO2, the charge becomes +4 to +3, means it is decreasing, means it is reduces by 1. So D is the correct answer, where it oxidizes as well and reduces as well. Question number 2. The diagram shows a Boltzmann distribution for 1 mole of gas. The gas takes part in a reaction with an activation energy EA, right? So the graph shows number of particles with energy E on the y-axis, and this is the x-axis, where it shows the energy of the molecules. Which statement correctly describes the effect of an increase in temperature? So you guys might know that an increase in temperature shifts the peak to the right and the peak below the original peak, right? So if I make this, it will become somewhat like this. This peak will be lower and this peak will shift to the right? So let's look at the options. Peak P will be higher. No, that's absolutely wrong. Peak P will be lower, yes, and for fewer molecules will have energy greater than. Oh yeah, so the activation energy would remain the same. However, this activation energy would increase. This would increase, the energy of the molecules would increase. So peak P will be lower and more molecules will have energy greater than the activation energy. This option is correct. 2D. Question number 3. So if you look at question number 3, basically this question is, I guess, misprinted, because the experiment 1 and 2 are exactly the same. 2 mole, the concentration is 2 and the temperature is also the same. Okay, so this is not a correct experiment, so that is why we'll not look at this option. However, if you look at experiment 3 and 4, we see that this is at room temperature, right? So room temperature, this will be a slow reaction, and means it will take more time. However, this will be a fast reaction and less time. But this question was eliminated because The options or the experiment 1 and 2 are exactly the same. Question number 4. The table shows the partial pressures in an equilibrium mixture formed by the Haber process. 3H2 plus N2 plus 2NH3, and the product is basically ammonia. And yep, so they're giving the partial pressures. We have to find the Kp, the equilibrium constant. So to find this, we have Kp is equals to P. The product will be on the in the numerator, and the reactants would be in the denominator. So P2NH3 upon Pn2 and dot P cube H2, right? So this is how we find, and the partial pressures are given, so we'll directly put in the values. Kp is equals to NH3 is 4000, so 4000 square upon nitrogen would be 7000 dot H2 hydrogen would be 8000 cube. So the answer for this would be, let me calculate. So 4000 square upon 7000 multiplied by 8000 cube. The answer is 4.46. 4.46 multiplied by 10 to the power minus 9. So this is A, 4A. So question number 8 says that in which species is there a lone pair of electrons? Lone pair of electrons, okay. So if we look at CH3 first, CH3. So C has a valence electrons, 4 valence electrons basically. So 1, 2, 3, 4, and there are 3 H's. So 1, 2, 3. But this is not a lone pair, this is a lone electron, a simple electron. So we do not have a lone pair of electrons though, right? So if we look at option C, because it's the correct answer, so we should look look at that, and I'll explain you guys. So C has 4 bonds. Wait, yes, C has 4 bonds, 1, 2, 3, 4, and H is 1, 2, 3, 3. Okay, so these are 3 electrons of H, but it has a minus sign here, which is the ion size, so it means it's gaining an electron, right? It's gaining an electron here. So there is a lone. These are this 1, 2, 3 are the bond pair of electrons, and this single pair is a lone pair of electrons. If we look at question number 9, under which conditions will nitrogen behave most like an ideal gas? This is the simplest question, which is repeated many times. So ideal gases have no volume, okay, they have no volume, and they have no IMF, which is the intramolecular forces, right? So for to behave like an ideal gas, it should have a high what temperature and a low pressure, because if it will have a low pressure, that means it has a less volume, right? So temperature high and pressure low, 9B, right? Yup. Question number 10. Yup. The equation for a chemical reaction is shown. All substances are in their standard states. Which statement describes the standard enthalpy change of reaction for this reaction? Okay. So have you guys realized what's the definition of standard enthalpy change of reaction? So I'll write for you guys. Wait a second. Yup. Of reaction. This says that energy change when not 1 mole, but when molar quantities of reactants react together to form products. Okay. Right. So which statement describes standard enthalpy change of the reaction for this reaction? So if you look at this reaction, wait a second, shit. Yep. So if we look at this reaction, right? So let's look at the options. The enthalpy change when a total of 1 mole. It's giving a quantity 1 mole. That's completely wrong. Not 1 mole. When the molar quantities react together to form a product. Okay. The enthalpy change when a total of 1 mole of reactants is reacted. No. The enthalpy change when 1 mole of water reacts. No. The enthalpy change when 6 moles of hydrogen fluoride are produced. When molar quantities are produced. Okay. So this would be 11. So question number 11 says molten aluminum chloride has a simple molecular structure, and each molecule consists of 2 aluminum atoms and 6 chlorine atoms, right? So Al2Cl6, right? So all the chlorine atoms in 1 gram of molten aluminum chloride have the same mass. That's wrong because chlorine has isotopes Cl35 and Cl37, so they do not have the same mass. A option is completely wrong, right? 1 mole of molten aluminum chloride contains 6.02 multiplied by 10 to the power 23 aluminum atoms. That's also wrong because it's not a simple Al, it's Al2. So 6.02 multiplied by 10 to the power 23 has to be multiplied by 2 to give an answer. So B is completely wrong. If you look at option C, it says 1 mole of aluminum chloride contains 3.61 multiplied by 10 to the power 24 chlorine atoms. That may be right, but let's look at it. Al2Cl6, right? So we have to multiply one molecule contains 6.02 multiplied by 10 to the power 23. We have to multiply this by 6 because 6 chlorine atoms are present. So let's do this. 6.02 multiplied by 10 to the power 23 multiplied by 6. This gives 3.6 multiplied by 10 to the power 24. Yeah. 11C. Which atom contains 4 times as many neutrons as the Li lithium atom? Right. So if we look at lithium atoms, the neutrons lithium has, they are basic 7 minus 3 is 4, and we multiply 4 multiplied by 4 is equal to 16. So we should get the answer which has 16 neutrons, right? This has 20 neutrons. This has basically this is the nucleon number, this is the proton number. So if we subtract this, we get the number of neutrons, right? So 24 minus 12 would give 12, but this answer is not matching. This 31 minus 15 would give 16. So C is the correct option. C is the correct option. Which statement about the first ionization energies of magnesium and neon is correct? Okay, so if we look at this, which statement? Okay, so let's make the periodic table in a simple rough manner. Okay, so this here we have an E neon at the last, and we have Na, Mg, Al, Si, P, S, Cl, and here we have Ar. Okay, so basically this is like this. Okay, so if you look at this, it says which has a greater ionization energy of magnesium. Which statement about the first ionization is correct? Right, so the ionization energy, we should know this fact, they are always endothermic, always endothermic, right? So if we look at this, we should read the options. Magnesium has a greater numerical value and both are endothermic, but we should look at the ionization energy first, right? So basically magnesium and neon has a greater numerical value of ionization energy because it's at the last of the period and it's before magnesium, right? So it has a complete shell, octet shell, and magnesium does not. So neon has the greater numerical value and both are endothermic. Yes, both are endothermic. So 13 is C. 14. In a sample of pure water, what is the maximum number of hydrogen bonds that one molecule of water can be involved in? Right. So this is basically, if we make a water molecule, H2O. Okay. So O has a lone pair of electrons, two lone pair of electrons and two bond pairs. So it can make a hydrogen bond here, 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 which is already made, here. So four total bonds. 15. Hydrated cobalt sulfate loses water when heated to give anhydrous cobalt to sulfate. All the water of crystallization is lost to atmosphere as steam. When 3.10 hydrated cobalt to sulfate is heated to the constant mass, the loss in mass is 1.39. Okay, so the loss in mass means the water. The mass of water is 1.39. If we have to find the mass of unhydrated cobalt to sulfate, so we basically 3.10 minus 1.39, which would give us a value of 1.39, and this would give us 1.71, right? And yup, which it's asking the value of x, the moles of water. So what if we compare the number of moles? What if we do that? That would be really nice enough. um hmm. So these are basically the number of moles. The It's a mass, right? So we have to find the number of moles. So for moles, we have mass upon mr, right? So this is H2O here, and the cobalt to sulfate. We have to find the ratio, right? So yup. The mass of water is 1.39 and this we have is 1.71. If we divide this by the mr, so cobalt 2 is 154.9 and H2O is 18. This would give 0.011039 and water would give 0.0772. Now we divide this by the smallest number, so which is 0.011039 divided by 0.011039, and this would give a ratio of 1:7. 1:7. So the number of moles in water would be C. The answer would be C, right? Okay, this was something big and messy. Yup. Question number 16. The table shows bond energies for some diatomic molecules. Deuterium D is an isotope of hydrogen, right? These are given the bond energies and which statements are correct, right? So if we look at this, basically deuterium is an isotope of hydrogen, and this has a nucleon number of 2 and 1. So basically D 2 and 1, right? um hmm. Let's read the options. Diatomic molecules of exact values for their bond energies, which are always positive. If we can see here, they are all positive values and they have the exact values for their bond energies, which is absolutely right, right? So A option one is correct, right? The trend in group 7 bond energies can be explained by the variation in instantaneous dipole induced dipole. No, because the bond energies gives the values for the covalent bonds, not the ID forces, right? The 2 is wrong. A value for the enthalpy change for the reaction between deuterium and chlorine can be calculated using the data alone. Basically, no, this cannot be given. Let's have a look at this. We know enthalpy change is equals to energy given in minus energy given out, right? Now here we have the energy given in. We have this energy, bond energy, but we do not have the enthalpy change. We do not have the energy given out. So how can we find this? So the value for enthalpy change cannot be given by this alone. So the answer is A, 16A. Two procedures are described. Sulfur is burned in an excess of oxygen, and the NO is added to the product mixture. All right. So sulfur is burned in an excess of oxygen, and this gives SO2, right? SO2 is then added to, and then NO is added. Okay, SO2 plus NO, right? So, okay, this gives the reaction SO3 plus N2. We balance this out, and if we look at option the statement number 2, so the same way S plus O2 gives SO2, SO2 plus NO2 gives us SO3 plus NO. Okay, so basically what happens is here NO and here the NO2 are both good oxidizing agents. They are both good oxidizing agents, right? So same the nitrogen monoxide as well and nitrogen dioxide as well. So sulfur trioxide would be produced by both of them, both 1 and 2. So if we have a look at question number 18, powder P is a mixture containing 2 of AgCl, AgBr or AgI, okay? Silver chloride, silver bromide or silver iodide. P is shaken with dilute aqueous ammonia. A yellow solid Q remains. So basically P should be AgCl because a white solid remains, which means AgI remains, and then the mixture is filtered and Q is washed and dried and the filtrate is collected. So the filtrate collected would also be silver iodide, and yup. So if we react this, so basically we would get AgCl plus AgCl plus NH3 ammonia, because this is saying dilute aqueous ammonia, NH3, which would give us AgNH3 2Cl to balance this out, okay? So yeah, so then this is saying that with aqueous nitric acid to produce a white precipitate R, which is filtered off, washed and dried. Q and R are warmed separately with concentrated sulfuric acid. Q and R जो हैं वो सल्फ्यूरिक एसिड के साथ रिएक्ट करते हैं. तो अगर हम इन दोनों को रिएक्ट करते हैं, फॉर एग्जांपल अगर हम रिएक्ट करते हैं AgI को H2SO4 से, तो हमारे पास बनता है AgHSO4 प्लस HSO4, and we'll get H hydrogen iodide. And if we react the same thing, if we remember this reaction, if we even do this silver chloride with sodium chloride, okay, sodium chloride plus sodium chloride plus sulfuric acid, which would give us NaHSO4 plus HCl. Now this is a reaction of R, this is Q. R we always remember HCl प्रोड्यूस हो रहा है, इसका मतलब कि हमारे पास स्टीमी फ्यूम्स प्रोड्यूस होंगी, ठीक है. और अगर हमारे पास HI बन रहा है, हाइड्रोजन आयोडाइड बन रहा है, तो दैट मीन्स कि हमारे पास वॉयलेट फ्यूम्स बन रही हैं, ठीक है. हमारे पास ऑरेंज फ्यूम्स नहीं बनेंगे, हमारे पास वॉयलेट फ्यूम्स बनेगी. सो दैट मीन्स 18 का आंसर जो है दैट इज. Okay, so question number 19. We have two period 3 elements X and Y that burn separately in oxygen to form solid oxides. Alright, the solid of X is insoluble in water, okay, and the solid of Y dissolves in water to form a solution which dissolves the oxide of X. Okay, so that means that oxide of Y, which will dissolve in water, will be more reactive than this oxide of X. So what could X and Y be? Okay, So let's make the oxides first of all. So for that we need so to dissolve basically one we should make a neutral solution. One should be acidic, one should be basic, right? So if we see at aluminum, which will make aluminum will make okay, so let's see. If we dissolve this in oxide, so this will make Na2O, Na2O. Phosphorus will make P4O10, and sulfur will make SO3. If we they're saying dissolve in water to form a solution, so the Y dissolve in water. When they will dissolve in water, so NaOH, and this will make the acid, which will be H3PO4, and this will make sulfuric acid. So these both are acidic, right? And these both are basic. For these two, the X should be basic, yeah. And for this, aluminum or magnesium should be acidic. So let's have a look at this. So basically, silicon SiO2, because they are dissolving in oxide, right? They're forming a solid oxide, and SiO2. Now these two are basically acidic. So acidic and acidic, they can't react. So C and D are absolutely wrong. If we look at this magnesium will also not react, because magnesium can't react with sodium, right? Because they both in group 1, they are both metals, so they can't react with each other. So basically, if we look at aluminum, this aluminum is amphoteric oxide. This will react with both acids and bases both. So for that, 19A. If we look at 20, which role describes the structure and bonding of SiO2 and SiCl4, right? So if we look at SiO2's structure is basically giant. Yep, giant. And SiO2's bonding is covalent, because Si is from the metal part and O2 is from the non-metal part. So they share electrons between each other, forming covalent bonds, right? So A or B. Then we come at SiCl4, which the structure of SiCl4 is simple. It's not giant. Simple. And if we look at bonding, so the SiCl4 also contains covalent bonding. So we have 4 ticks for our B. So B is the correct answer. B is the correct answer. 21. A sample containing 0.01 mole of anhydrous calcium nitrate is heated strongly until it fully decomposes. All the gas produced is collected and its volume measured at room conditions. What is the volume of gas produced? Alright, so if it's better if we make equation for this, right? Because we are decomposing anhydrous calcium nitrate. So let's make equation for that one. CaNO3 2 calcium nitrate will decompose to make calcium oxide, NO2, and it will make O2. To balance this, we have to put 2 here and 1. So now it's balanced, if you guys see. Okay, so if it's saying that 0.01 mole of anhydrous calcium nitrate, alright, heated strongly until it fully decomposes, all the gas produced is collected and its volume measured at room conditions. Alright, so Okay, so basically they're asking for the volume of gas produced. Now if you guys notice carefully, the gas is not only the O2 here, it's NO2 as well, right? These both of them are gases having a molecular sum of 2.5 moles. So if 1 mole of calcium nitrate, if we're writing here 1 minute, 1 mole of calcium nitrate is equals to 2.5 moles, then how much is 0.01 moles equals to? We have to find x. So x is basically 0.025. Alright, and if we have to find the volume of gas produced, so 1 mole will be equal to 24,000 cm3, and they're asking for 0.025, which would be x. So 24,000 multiplied by 0.025, which would give us 600. B is the answer. 22. V and Z are both elements in period 3 of the periodic table. Each element forms one stable ion that does not contain another element. Alright. The atomic radius of each element and the ionic radius of the ion described above is shown. Which statement is correct? Alright. So for this we have to get a knowledge of the periodicity and the trend between the atomic and the ionic radiuses. So let's read the options. Ions of V and Z have the same number of electron shells. That's absolutely wrong basically, because if you guys notice here, let me show you a thing. The atomic radius is smaller than the ionic radius, right? The ionic radius is larger. That means the electrons are more. This is an anion having a negative charge. However, this atomic radius is greater than the ionic radius. So that means this has less number of electrons, which means a positive charge, a negative charge. So one of them is a cation and one of them is an anion. So that is why A is completely wrong. Ions of Z are positively charged. Ions of Z are not positively charged because as I told you guys, the atomic radius increases. So that means the ionic radius should decrease here. If it's saying it's positively charged, so ionic radius should be decreasing, not increasing, right? Z has a greater electronegativity than V. Z has greater. Okay, so basically let's see. As you guys know, this is a period, right? And the atomic radius would decrease across a period. So the trend, the periodic table would be like V and then Z here. If the atomic radius decreases, the electronegativity should increase. So Z has a greater electronegativity than V. This is absolutely right. Question number 23. In group 2 of the periodic table, the properties of the elements and their compounds show regular change down the group. Which property shows a decrease from magnesium to barium? Okay. So, the decomposition temperature of the carbonates. No, this does not increase. This does not decrease. This increases. The decomposition temperature of the nitrates. No, the nitrates also increases, does not decrease. The solubility of the hydroxides. The solubility basically increases, it does not decrease, because the stability depends on this, affects a lot. And the solubility of the sulfates. Yeah, the solubility of the sulfates decreases down the group. That's absolutely right. From magnesium to barium basically. Four properties of beryllium or beryllium compound are listed. Which property is different from the property of magnesium or equivalent magnesium compound? Okay, beryllium reacts with O2 when heated in air, magnesium does not. Why does it not? Magnesium also does react with oxygen, right? Yeah, magnesium does. Beryllium reacts with aqueous sulfuric acid to form a metal sulfate and hydrogen. Magnesium does not. Magnesium does. Magnesium does react with H2SO4 and to form metal sulfate, to form magnesium sulfate. This is wrong. Then this is saying that beryllium nitrate decomposes on heating to form a metal oxide NO2, O2, and magnesium nitrate does not. But magnesium nitrate does react. It decomposes to form NO2 and O2. It does. So, yeah, wrong. BeCl2 reacts with water to form fumes of HCl. Magnesium chloride does not. Why do I think this is right? Oh yeah. This is absolutely right. This is absolutely right because beryllium is basically a non-metal. It's a non-metal because of its smaller size. Small like ionic radius, smaller size, and it forms covalent bonds. However, magnesium chloride does not. It does not have a smaller size, so it does form covalent bonds though. So yeah, D is the correct answer. Let's move to the organic part. Now is where the organic part starts from question number 25. So which two formula correctly represent a pair of structural isomers? So let's do this. The answer for this is basically D. So let's have a look for the D one only. CH3, CHH, CHH, COOH, and we have C here, right? CH3, CH3, and we have 1 second. Yup, we have H here, C here, OH. So basically, don't you guys think this is a pair of structural isomers? Because what happens is that this part, this unbranched part, becomes a branched part here. This carbon number 1 has 2 carbons on the branch. So basically, D is the correct answer. Which reagents and conditions will result in the formation of butanylnitrile CH3, CH2, CH2CN? Alright, so let's make this. Would result in the formation of butanylnitrile. Okay. Let's have a look at question the part with the option number B. Okay, it says 1 bromopropane, so met et prop, like that means 3 carbon, and 1 2 3, and we have a Br here because this is our carbon number 1, this is our 2, this is 3. So this is 1 bromopropane, which is heated with potassium cyanide and ethanol. So this is KCN, which means it is alcoholic, and it makes the CN would be removed by Br, so it would attach here. CH3, this is basically a step-up reaction if you guys remember. CH3, CH2, CH2, and we have C triple bond N here. So what it's asking for, CH3, CH2, CH2CN, right? This is our formation. So question number 27 says that compound X C7H13Br reacts with hot alcoholic NaOH and to produce 2 compounds Y and Z, right? So basically, if you guys see, this is an elimination reaction, because if we use alcoholic NaOH, that means they are the reagents for an elimination reaction. And reaction with Br2, gives the product C7H12Br2, and it's a mixture of 4 optical isomers, right? So optical isomers means 4 different bond groups, tetrahedral, and on reaction with Br2, Z gives the product C7H12Br2, which is non-chiral. What could X be? So if you guys have a look at this, X could not be B, because B has just a single bond, right, out of this group. So that is why it can't make 2 products, Y and Z. So basically B is not the correct answer. B is like absolutely wrong. If you have a look at A, so let's expand this. Let's make a formula, like let's expand this thing. So basically let's do it here, right at the end. Yes. So it's saying we have um, so we have C and we have a methyl group here, right? And then we have Br here, then we have C, 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 and we have a C here. So 1 2 1 2 1 2 1 2 and 1 2. Alright, so carbon has 4 bonds, that is absolutely correct. If we react with this with OH, which is alcoholic, so this will basically make two products. Two products would be double bond O here, right at this part. Basically, let me show you. Shit. At this part, one double bond, and then we have to make a double bond which we have to react with OH right here. Okay, so basically let's do this. We have methyl here and we have a double bond here, right here. We can make it anywhere. Let me show you guys. Like for example, if I told you guys to make a double bond here, you can also make it here, you can also make it here, you can also make it here. So you can make multiple double bonds, but they're saying two different products, so the products would be same because the numbering would be same. So that is why I'm making on only one of them. So basically I'm making on this one, right? And then they are asking to react that with bromine. So to react with bromine, basically this will change, this will not remain the same, the double bond won't remain the same. So carbon, 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 and carbon right here. Yup, carbon, and then we will react this with Br and one of, क्योंकि यहाँ पर एक bond है, दो bond है. Wait, let me make this correct. This is one bond, okay? This is single bond. One bond here, one bond here, one bond here, and there is no bond here. So there are three bonds. So that is why I'm making a fourth bond as well, which is CH2Br, okay? Because there are two Brs, so that is why. And this, if we react with Br2, so this would become like this. Because now here there would be a methyl group and here there would be a bromine. So there are two different products which are basically, let's see the question now. So question number, what's it? Question number 27. Yeah, so it says to produce two different compounds Y and Z, which we were getting the correct answer. On reaction with Br2, Y gives the product C7H12Br2, and which will have 4 optical isomers. So let's have a look. C7H12Br2. So let's count. Basically 1 2 3 4 5 6 7 H12, 1 2 3 4 5 6 7 8 9 10 11 12, and this will be C7H12 and Br2, and 4 different chiral carbons. So that is why this would be basically 1 2, and yeah, so this has a 4 optical isomers, right? So that is why the correct answer for this one would be A. Question number 28. Question number 28 says that when elutin S is heated under reflux with an excess of acidified potassium dichromate, compound M is formed, right? What is the molecular formula of compound M? So this is our group, like this is a skeletal formula, and we have to react this with acidified potassium dichromate, which means we have to put OHs. So to form OHs, what will happen is that this group, these groups would be changing into double bond O. This would also change into double bond O. So, yup. So we'll have less hydrogens, more oxygens. So, yup. Let's make this. This is question number 28, right? Question number 28. And we are given this carbon, ऊपर से है CH3, यहाँ पर है एक कार्बन, यहाँ पर है CH2, यहाँ पर है CH2, और यहाँ पर आ गया हमारे पास नीचे कार्बन एक और, यहाँ पर आ गया CH3, यहाँ पर आ गया OH, यहाँ पर आ गया वेट वन सेकेंड, यहाँ पर आ गया हमारे पास एक और कार्बन जिसके पास डबल बॉन्ड O है, यहाँ पर है हमारे पास कार्बन, और यहाँ पर है हमारे पास कार्बन, and this carbon has a double bond. Okay, so this carbon and this carbon has a double bond O, and this carbon and अच्छा, दूसरी बात मैं आप लोगों को बता दूं कि यहाँ पर डबल बॉन्ड क्यों आया है. Basically, you guys don't have the question basically, so you can't recognize this, but this does not have a double bond O in the question. This has a OH like this. If we react it with potassium dichromate, this will become double bond O. Okay, so that is why I changed it to this. If we have a look, basically I'll show you guys. So have a look at this. This is a OH group, and this voila, and this also has a OH group. This does not. This has a simple double bond O, so I just made it. एंड यप, सो सी डबल बॉन्ड ओ यहाँ पर आ गया, सी आ गया, और इसके बाद अगर हम आते हैं तो दिस वुड हैव CH3 एंड सी डबल बॉन्ड O, OH, एंड basically not here, this would be right here, CH, और इस कार्बन और इस कार्बन के बीच में है डबल बॉन्ड. ऑलराइट, नाउ दिस इज़ अ होल स्ट्रक्चर आई मेड. एंड यहाँ पर अगर आप ये रियलाइज़ करना, यहाँ पर डबल बॉन्ड O आ रहा है, यहाँ पर डबल बॉन्ड OH आ रहा है. ये इसलिए आ रहा है बिकॉज यहाँ पर हमारे पास स्पेस नहीं है. कार्बन के ऑलरेडी 4 बॉन्ड्स बन चुके हैं, यहाँ पर नहीं बन चुके. 1 2 3 और ये 4 बना है. सो दैट इज़ वाई मेरा OH ग्रुप राइट हियर. सो दैट इज़ वाई आवर आंसर, लेट्स काउंट, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 and 15. So C15 and wait, C15, and then let's count the H's. 1 2 3 4 5 6 7 8 9 10 11 11 के बाद 12 13 14 15 16 16 8 16, एंड देन O काउंट करते हैं तो O पे 1 2 3 4 5 4 5, C16 8 16, C15 8 16 O5. So C15 8 16 O5 कहाँ पर है? ये रहा, B. 28 is B. 29 की अगर हम बात करते हैं, so basically this is a VSFR question which is mainly easiest among all of them. So yeah, cyclohexane C6H10 is a hydrocarbon with 6-membered ring of carbon atoms. This has several isomers that straight chain alkenes, a number of double bonds and each. अच्छा, एक और चीज़ आप लोगों को बता दूँ कि फॉर एग्जांपल यहाँ पर अगर 6 कार्बन है, C3 4 5 6, ठीक है. अब यहाँ पर अगर हम फॉर एग्जांपल हमने कोई भी डबल बॉन्ड नहीं बनाया, तो आप लोग काउंट तो करें, 1 2 3 4 5 6 7 8 9 10 11 12 13 14, ये 14 से मैच करे तो 10 है यहाँ पर. अगर आप यहाँ पर कहीं पे बीच में कार्बन डबल बॉन्ड लगा भी लेते हैं, फॉर एग्जांपल अगर आप लोग यहाँ पर लगा लेते हैं, ठीक है. अब यहाँ पर कितने बन जाएंगे? ये 2 बॉन्ड हैं, 1 2 3 4 5 6 7 8 9 10 11 12. These are 12 what? 12 hydrogen. But we have to make how many? We have to make 10. So that is why we'll make a double bond. एक और भी बनाएंगे हम लोग. तो फॉर एग्जाम्पल यहाँ पर बना दिया हमने. अब कितने हो जाएंगे? 1 2 3 4 5 6 7 8 9 10 11 12. No, wait, what? Wait. Let me see. 1 2 3, यहाँ पर 3 एक तीसरा होगा, बिकॉज 3 बनने में एक और होगा, 3 4 5 6 7 8 9 10 10 हो गए। तो हमारे पास 2 डबल बॉन्ड्स हैं। अगर हमारे पास 2 डबल बॉन्ड्स हैं, दैट मीन्स दैट वी हैव अ नॉन प्लेनर शेप which and the number of double bonds in each of the values is p. नंबर ऑफ डबल बॉन्ड्स हमारे पास 2, अगर 2 डबल बॉन्ड्स होंगे नॉन प्लेबल होगा, डी आंसर। If we talk about 30, exhaust gases from internal combustion engine are made less harmful by passing them through a catalytic converter. A number of reactions take place in the catalytic converter. 2 such reactions are described in the table. Which row is correct? The type of reaction that removes carbon monoxide. Okay, so that is basically oxidation. Alright, because carbon dioxide monoxide, nitrogen dioxide monoxide react to form N2 plus CO2. So basically this is oxidation. The type of reaction that removes unburned hydrocarbons, this is also oxidation. So A is the answer. For 31, which compound reacts most rapidly with aqueous silver nitrate by an SN1 reaction? So basically if we're talking about SN1 reaction, so let's have a look at option number D, because that's the correct answer, so we have to like just explain for that. 2-iodomethyl propane. Okay, so 2-iodomethyl propane will basically make 1 2 3 propane, and then we have 2-iodomethyl, so basically 1 2 3, this will be I here and CH3 here and CH3. Alright, so this will make a SN1 reaction by aqueous silver nitrate, and this will make a SN1 reaction because this is a tertiary one. Okay, so if we have a look at this will, what it will do is that it will make a carbocation, CH3 here, CH3 here and a CH3 here. So basically this is the correct answer only. Tartaric acid HOOCCHOH CHOH C double bond OH. Okay. It's found in many plants. All right. So what happens is that sample of tartaric acid reacts with an excess of LiAlH4 to form organic product J. What happens when NaOH is added to separate samples of tartaric acid and J? So they're asking whether tartaric acid will react और जे। अच्छा, अगर हम इस चीज़ को, एसिड को अगर हम रिड्यूस करते हैं LiAlH4 से, तो हमारे पास बेसिकली अल्कोहल बनता है। तो अल्कोहल जो जे है ना हमारे पास, दिस इज़ बेसिकली अल्कोहल। तो आप लोगों को क्या लगता है कि कौन रिएक्ट करता है NaOH के साथ? सो बेसिकली द आंसर इज सिंपल, वी कैन easily recognize the answer, but basically let's have a look at the explanation for this one. I'll make this for you guys, okay? HO C double bond O, this is CHOH, this is CHOH again, and this is C double bond OH. So basically this is what they asked me to make the tartaric acid, right? अब बोलते हैं कि इसको जो है LiAlH4 से जो है आप रिएक्ट करवाएं, उसको रिएक्ट करवाएंगे तो ऑब्वियसली आपके पास अल्कोहल तो बनेगा। अब अगर आपने इसको रिएक्ट करवाया तो बनेगा क्या असल में आपके पास HO, यहाँ पर आपके पास बन जाएगा CH2, क्योंकि ये तो आपके पास रिमूव हो जाएगा ना, ये वाला जो थिंग है ये तो आपके पास रिमूव हो जाएगा। तो CH2 यहाँ पर आपके पास बनेगा फिर से CH, यहाँ पर हो जाएगा OH, CHOH, यहाँ पर बन जाएगा CH2 और ये बन जाएगा OH। तो ये बता रहे हैं आपको कि दिस इज टेलिंग अस दैट दिस इज एन अल्कोहल। सो दिस थिंग इज J and this thing is acid. So basically now tell what will react with NaOH. So if you guys have some knowledge, acid does react with sodium metal, sodium oxide, sodium hydroxide, sodium carbonate, but alcohol only reacts with sodium, does not react with sodium metal. Okay, it does not react. So basically the answer for this is only tartaric acid reacts, B. So question number 33. Citric acid can be converted into tricarboxylic acid in 2 stages. An intermediate Q is found, alright? Which reagents are needed for this stage? So basically, to form Q, an intermediate, the stage 1 should be dehydration. Okay, it should be dehydration. And to dehydrate it, we need concentrated sulfuric acid. Okay, this is for reduction, this is NaOH, and this is for the this is needed for basically halogen alkanes elimination reaction, and this is for the dehydration purposes. So A or B. Now if you guys look at stage 2, so basically if we react this if we hydrate this simply, if we hydrate this simply, so basically we'll get the acid again. So that is why we need H2 and Ni, the reactant, the reagents basically. So the answer for this will be A.